Hello students. So it's good to be back again. I'm your course instructor Shankar Mahato, and I'm an assistant professor at the Indian Institute of Technology Kharagpur. And today I will be live for 1 hour, and if you have any questions related to the course, you can ask me. The questions can be also based on the concepts which I have taught, and it can also be motivated from the assignments or any question that may come up in your mind. You can ask through the chat, and I will try to address all those questions. One or two questions that I do remember from the forum, which some of the students have asked. So the very first question is, why do we need Riemann integration? So I believe some students have asked the question motivated from the first lecture and also first assignment. So the thing is, up until your +2 level or your higher secondary level, where you did the integration, there the functions were really nicely behaving functions. So you really didn't have discontinuous functions or functions which have multiple discontinuity in the given range of integration. So basically the functions which we dealt with, they were continuous functions in that given interval. They could also be differentiable functions in that given interval. So they had very nice behaving properties. Now once you advance through the analysis courses, you come across functions which are not that much nicely behaving. So once you get into more real world applications, there the functions that will come from those real world applications, they will not be that much nicely behaving functions. So they could be discontinuous, they can also have infinite discontinuity, jump discontinuity. They may not behave nicely in the given range of integration. So at best you will have is, let's say, the bounded functions in the given interval. So they might be discontinuous at 1 or 2 points, and the best thing that we can get out of it is that the function is bounded in the interval a to b where you are doing the integration. And then our usual Newtonian integration will fail. So the functions which were nicely behaving, so that we could do the method of substitution, like putting x square equals to z and simplifying the integrals, those tricks will not work directly here. So that is called as Newtonian integration, and that will simply not work here. So then you need some alternative way to perform the integration, and that is when the Riemann integration comes into the picture. So there basically what you have is having a bounded function just in that given interval, you can be able to perform the integration. So I think during the lecture also I have addressed a theorem that if you have a function with a finite number of discontinuities in the given interval a to b, then that function is Riemann integrable. And that is one of the important aspects of the Riemann integration, that if you have even a discontinuous function, all you need is the boundedness in that given interval, and then you can perform the integral. And that is a really good how to say, aspect of the Riemann integration, that it gives you that flexibility to perform the integral even for a discontinuous function in a given range of integration. So that was the first question that I wanted to address. Second question was I don't recall the name of the student, but I think second question was what is infimum and supremum. So as I tried to answer in the forum itself, that when you have let's say a function f defined on an interval a to b, I prefer to write this. So suppose you have a function f mapping from a to b to r, and it is differentiable at least once. So, you can, that means that is f dash x exists on the open interval a to b. So, it means that if you plot this function, let us say or this is y equals to f x. So, if you plot this function, let us say this function is this one. So, basically if the function is differentiable at every point a to b, suppose this is my point x equals to a and this is my point x equals to b. So, basically what we are trying to say is that the function is differentiable at every point a to b. That means, you can be able to draw the tangent at every point. So, f dash x exists, it means that the derivative dy dx is equals to slope of the tangent. I hope you have learned that concept. So, basically it means that the tangent will exist at every point between a to b, and if the tangent exists, then we can at least talk about the maximum and minimum. So, that means if you have a very nicely behaving function, when I say nicely behaving, it means that it must be differentiable at least once. Now, it can be differentiable twice, thrice, 4 times. We are not concerned about that. We are just concerned with the fact that whether it is differentiable once or not. So, if it is differentiable once, that means it will have maximum and minimum at in that given interval a to b. So, you can talk about whether the function how to say attains its maximum and minimum if the function is differentiable on the interval a to b. Now, suppose the function is not differentiable, it is just continuous on the given interval a to b. So, it may happen that the function is only continuous. So, it is so the given fact is that the function is only continuous, but it is not differentiable. So, that means you cannot be able to draw the tangent at every point in that given interval a to b. So, it also means that we may or may not have the maximum and minimum on the given interval. All right. So, if we do not have a maximum and minimum on the given interval, then we can at best talk about as the supremum and infimum. So, supremum and infimum, they usually come from one more terminology which are called as least upper bound and greatest lower bound. So, least upper bound and greatest lower bound are usually motivated from lower bound and upper bound. So, imagine you do not even have a continuous function on the entire interval a to b, you just have a function defined on the interval a to b which is bounded. So, it is given to you that the function is bounded on the given interval a to b, and that is pretty much it. So, if it is bounded, then it will have a lower bound and it will have an upper bound. That is it. It may be discontinuous on the given interval, it may have more than one point of discontinuity, but that is not something we are concerned with. We are only concerned with the fact that it is only bounded. So, it has a lower bound and upper bound. Now, if it is given as a continuous function, so you can divide the given interval a to b into several sub intervals, and in every sub interval you will get a lower bound, you will get an upper bound. So, continuously you will get a lower bound and upper bound, and taking the maximum of all the lower bounds, that will give you the infimum, and taking the minimum of all the lower bounds, that will give you the supremum. So, hence greatest lower bound, that means the greatest of the lower bounds, whatever lower bounds you will get after dividing the interval a to b into, let us say, n sub intervals, and similarly obtaining least upper bound, which is called as supremum, by taking the least of all the supremum in those n sub intervals. So, that is how we define the supremum and infimum. All right. So, if your function is discontinuous on a given interval, then you can only talk about lower bound and upper bound. If it is continuous on the given interval, then you can talk about least upper bound and greatest lower bound. In other words, infimum and supremum. If your function is differentiable on the given interval and at every point of the given interval, then you can talk about minimum and maximum. So, there are 3 or 6 important terms which you have to keep in your mind: lower bounds, upper bounds, infimum, supremum, maximum and minimum. And they all these terminologies, they are different from one another, and they have some meaning and some, in fact, some important meaning in real analysis or in differential calculus and in other branches of mathematics. All right. Let me just browse through the forum so that I can address some more questions. So I am going back to the forum. So all the questions raised by the students on the forum, I itself answered them, all those questions. I hope you were able to get the answers, and if not, then you can write me the questions on the forum, or you can ask on the chat as well. So, one more question from the forum that I would like to address is the partition of an interval. So what do we mean by the partition of a given interval? So the partition of an interval usually mean that you take all such small partitions of a given interval a to b. So that means if you have let us say an interval a to b, so the first possible partition is to take n equal subintervals. So like x1 x2 x2 x3 x4 x3 x4 and so on, and the length of each one of these subintervals is kept to be same. All right, and that endpoints which we have chosen, that could act as one partition. Similarly, you can have let us say another combination of the partitions where you take the length as a different step length, and then you create one more partition and so on. Now, when we say that the non-overlapping interval, I believe one or two students have asked that the endpoints are common. So the thing is, except the endpoints, there should not be any other common points. That's what we mean by the non-overlapping interval. So when we are saying that it is a non-overlapping interval, that does not mean that x1 x2 intersection with x2 x3 will be some other interval, right? So we only have one common point, that is x2. Because if you do not take x1 x2 and then x2 x3, then what would happen is if they are disjoint, then in that case you have to write something like x1 x2, and then we cannot be able to find the point immediately next to x2, so that you can construct another non-overlapping interval. So you have to keep x2 x1 x2 and then x2 x3, so that there is a continuation of the points as well. So that is how the non-overlapping interval meant here. All right. So when we say non-overlapping, except the endpoints, there should not be any other common points. In the chat, I got one question that can you explain assignment 1, problem number 6. So let me open the assignment 1 in my computer, and then I will go to the question number 6. Assignment 1, question number 6. So yes, the question number 6 in the assignment 1 is I have defined a Dirichlet function, which is defined by f(x) equals to 1 when x is non-zero and is 0 when x is 0. So here of course the function is bounded on R, because it has lower bound as 0 and upper bound as 1. So it is a bounded function on R, and if it is bounded, then it is Riemann integrable. And if it is bounded, then it is, yes, it is a bounded function on R, and therefore we can be able to find out the Riemann integrable, the integrability of this function, and therefore option B and D, the option B and C would be the correct answers. So here I have option B and C as the correct answer. So, I believe one student has raised a remark that in the assignment itself the correct answer was given as B and D. So, D should not be the correct answer. The correct answer should be B and C, that is the function is bounded on R and the function is Riemann integrable on R. Yes. So, I have my assignment 1 opened here and the correct answer is B and C, which is it is a bounded on R and it is Riemann integrable on R. Week 3, question number 12. All right. So, I have got one more question from another student. He is saying assignment 3, question number 12. All right. So, assignment 3, question number 12. Let me go to assignment 3, question number 12. All right. So, assignment, I believe the student meant assignment 3 and question number 12. So, since he has not mentioned the assignment number, it's a little bit difficult for me to know which assignment is he talking about, but I believe it's assignment 3. So, question number 12 is basically an application of gamma integral. So, I believe I have given several formulas about gamma functions, where we have the duplication formula, we have a connection between beta and gamma functions. There is one more formula about gamma functions which I am going to write, and it is an application of that gamma function. So, since I have recommended several books for you to read, it is not only the things which I am teaching on NPTEL forum, those are the things which you are concerned of. You should also browse through the books which I have recommended at the beginning of the lecture, so that if one or two things if I am missing out, because sometimes they are also too basic, and also sometimes due to the time constraint if I am not covering it, but since it is not that much difficult, I may skip. But most of the time I will try to cover everything as much as possible. Now, this is just a simple application of a gamma formula, gamma function formula, sorry. So, I am just going to write down that let us say remark a gamma function remark, and so the formula goes like this. I have to so the formula goes like this: gamma 1 by n, gamma 2 by n, dot dot up to gamma n minus 1 by n is equal to is equal to 2 pi to the power n minus 1 by 2 divided by n to the power 1 by 2. So, this is just one simple application of this formula, and this formula is very standard and you can be able to find in any book. So, basically if you in our case, let me open the assignment. So, in our case n is 9 sorry. So, if n is 9, so you just substitute n equals to 9, and then we will get here gamma 1 by 3, gamma 1 by 9, gamma 2 by 9 up to gamma 8 by 9 equals to 2 pi whole to the power n minus 1 by 2 divided by n to the power 1 by 2. So, this can be calculated very easily and that will give you the required answer. One student has recommended how to download the books. Honestly, I have no idea how to suggest you to download the books. You basically have to buy them or look for those books in your library if those books are available. All right. So, I have no suggestion regarding the downloading of the books. One more question. Can you explain assignment 2, question number 9? So, let me open assignment 2. Question number 9. Where is question number 9? So, here the integral 0 to 2 dx by 1 minus x square is convergent. So, this one is quite simple to check. So, check the convergence at x equals to 1 and that will give you the answer whether it is convergent or not, and you also have to submit the answer so that the evaluation can be done. As far as verifying the question, so I will verify the question and update on the forum whether if there is any error in the question or not, but I would recommend, since the point of discontinuity is at x equals to 1, you just verify the convergence at x equals to 1 and submit your answer. Okay, one more question that has come up is this course helpful for GATE EE? Also, I also don't, I mean, again in this case I have, I cannot say for sure that if you study this course then it would help you in GATE or not, but most importantly this course is very important if for any branches of students, whether you are from engineering background or whether you are from pure science background. I mean, this is the first course that you will study in your first year of BTech or BSc, and from that perspective it's a very important course. You must know integral calculus and vector calculus. As far as my impression is, GATE examinations are a little bit advanced, so there the questions will be more advanced, and the courses which you are the course which we are talking about, it's a very preliminary and elementary course which sort of makes your background stronger. So from that perspective it is a very important course. You must know all the aspects of integral calculus and vector calculus, but from any examination point of view I simply cannot make any comments there. I am just looking at some more assignment questions on the forum so that I can ask, I can address them. Let me browse through the portal so that I can help answer some more questions. So, okay, one student have asked, Riemann integration is only used for discontinuous function, as f(x) equals to x is continuous function, but LPF is not equals to EPF. No, this is not true. So, the entire question is not correct. First of all, if a function is how to say is Newtonian integrable, then it is always Riemann integrable. All right. So, f(x) equals to x, it's a very nicely behaving function, honestly. So, it will be Riemann integrable, as well as it will be Newtonian integrable given on a finite interval, interval, say from a to b, where a and b are both finite. Also, if a function is continuous throughout an interval, then it will be always Riemann integrable. So, there is no such stipulation that it has to be discontinuous, so that then only you can perform the Riemann integration. There is nothing like that. If it is continuous, it will be Riemann integrable, and the function which you have proposed here, f(x) equals to x, it will be Riemann integrable, and here in this case LPF will be equal to UPF. So, I think the student may have confused, but this is for Riemann integrable. Let me go to one more question. One more question in the forum. All right. So, I believe there are no more questions in the forum that I can address here. Some students have asked about the reference book. I am just going to repeat the books which I prefer to follow. So, first one is Mathematical Analysis by Apostol. This is a very classical book. Then Introduction to Analysis by Bartlett-Shebert, that one is also very classic. Real Analysis by Redon, and Principle of Mathematical Analysis by Rudin. These are some of the very old and classical books on analysis. Basically, if you want to learn about Riemann integration and all that. You can also follow some Indian authors books if you are interested. So, that is up to you. All right, and I have got one more question. Please suggest which books for engineering mathematics to solve quickly and tricky. First of all, mathematics is all about learning through the topic. So, there is no quick way to solve the problems. It depends on you how well you practice, so that you can be able to solve them quickly. So, that particular knowledge or that particular aspect must come from you, not from there is no certain tricks that I can simply teach you, so that you can be able to solve. So, trick part, I do not like to use any kind of word that closely matches with tricks. So, in mathematics, tricks are not there, it is just that you got perfect in it. So, now you can simply use some shortcuts to solve a problem, but mainly you got to know about those shortcuts because you got perfect on that topic. All right. So, the books which I have recommended, you have to learn through them, you have to go through them, you also have to go through my lecture and understand the topic, so that you become good at it, and then you can apply those shortcuts or tricks that will help you solve the problems. But I believe in practice you have to work out a lot of examples, so that you can be good at it, and then you can apply those tricks or shortcuts. I think one student have asked any math textbook for GATE. I cannot tell you any math textbook for GATE, so you have to find by yourself. You can ask me questions related to the course only, all right, and I can tell you the books related to the course. Again, you are asking me all these gate related questions. I cannot help you with any one of those gate related questions. So, please do not ask me how to prepare for gate from NPTEL videos. I mean, it's totally up to you how you want to use the NPTEL videos. I mean, it's not only my course, there are thousands of other courses that are available on NPTEL forum. Now, depending on the gate syllabus, open the gate syllabus, look at the subjects which are there and see what are the courses that can teach you those subjects. It's as simple as that. I have no idea how to suggest you to prepare for GATE or NATE or any such competitive exams. One student have asked assignment 2 question number 4. So, I am going to open assignment 2 question number 4. So, this is assignment 2 question number 4. Yes, the integral 0 to a x to the power 5 2a square minus x square whole to the power minus 3 d of x is equal to certain value. Yes. So, here you substitute x equals to as I have suggested, the hint is same as question number 3. So, since these are all basically some definite integral that will reduce to some kind of beta function or gamma function, I have not worked out the detailed calculation, because I believe you have done these kind of integral in your +2 level. It's just that you need to simplify a little bit, that's pretty much it. So, you substitute x equals to square root of 2 a sin theta, and then everything will reduce into some sin theta, and then I don't know, some cos theta, and here you will have some sin theta, and then you use some reduction formula. So, here applying some reduction formula will give you the required result. Yeah, that's pretty much it. I mean, it's a very straightforward problem. Some student have suggested, sir, I am from diploma background, I joined BTech from second year, there I don't have any mathematics in BTech. Yeah, so if you don't have any mathematics there, I think not only my course, but there are several other courses that are available on NPTEL forum, from where you can learn a lot about mathematics. So, I believe there are courses on real analysis, differential equations, algebra, modern algebra. When I say algebra, it means modern algebra, linear algebra, functional analysis, numerical analysis. So, you just have to go and on NPTEL website and then select only mathematics courses, and there you will find whole bunch of suggestions, including my course as well. And you can ask your teachers what are the courses that you do need throughout your BTech, and then he or she can suggest you a certain number of courses, which I am 100% sure that all of those courses must have been taught by 1 or 2 faculties from other IITs or ISC. So, just look at those course videos, learn from there. like you are doing from my course, and also look at the references which they are talking about, books which they are talking about, and that's how you learn. If you have any more questions, you can keep on asking. Okay, so one student have asked, I don't know about NPTEL exam, please can you explain briefly. So NPTEL exam, at least about my course, the exam will be conducted online. I believe you have to register for it, and I don't know exactly, but you may have to pay for the exam, but that you have to verify from the NPTEL office itself. So since I'm just a faculty who is taking the course, I am not aware of the administrative issues. For that you have to send an email or call the local NPTEL office under which you have registered for the course. So the exam will be conducted online. I think it will be a 100 marks question and MCQ type exam or something like that. But I'm pretty sure it will be an online exam. I'm not aware of the question types or the procedure. So for that you have to contact the NPTEL office. They will be able to tell you more in detail. One student have asked, can we learn engineering maths with somewhat weak base in class 12 maths? I believe yes. So if you have a basic knowledge of mathematics from +2 level, you should be able to learn mathematics that is more relevant to your engineering mathematics. Because I mean, you do need to have some knowledge or some working technique with the help of which we solve problems or we understand a topic in mathematics. So, having a small background or at least basis of mathematics from your +2 level would definitely help, and I am pretty sure you can be able to learn your engineering mathematics. Now, what will be the correct way? These are all philosophical questions, and I cannot be able to help. My way of learning mathematics is learning by doing. So you have to do a lot of problems, you have to study at least 2 or 3 books on a single topic, basically, or on a single subject, to have a good grip on that particular topic, and then you solve some problems, in fact lot of problems, if you want to be really good at it, and that's how you master that particular subject. So keep on practicing, that is the key. As I told you, to ask only questions related to this course. I cannot tell you anything about internship or any such things. So it's of no use if you ask me those questions. First of all one student have asked what is the best book for analysis. Honestly, I don't know. So they are all very good books, and they are all very classical books on analysis, and have been followed by numerous teachers. So you can pick any one of them and start reading, and they are all very good. When next time live class to our course? Okay, so the next session would be somewhere in March. You will be notified by our local NPTEL office. They will send how to say, an update on it, and it's probably next month, somewhere middle of the month, I guess, but I don't know the exact dates. One student have asked why continuity for multiple variable functions depend upon the contour we choose to approach the limits. So, why continuity for multiple variable function? Okay, that I think you are talking about functions of several variables which are not in this course. But anyway, the answer is very straightforward. So, I will just give you a 2-line answer. If you want a detailed answer, then you have to look into the book. So, basically for function of 2 variables, when you are passing on the limit, so there are 2 ways you can pass the limit. So, the first one is iterated limit. That means you are first making y go to 0 and then x go to 0 if you are evaluating let us say limit going to 0 0. And then there is a simultaneous limit where you make both x and y going to 0. Now, in case of simultaneous limit, when you are making both x and y go to 0, it depends on how it is approaching to 0. In case of function of one variable, you have, when you say x going to 0 or x going to a, it is always unidirectional. So, x going to a. But when you talk about in case of function of 2 variable, when you have two dimensional geometry, and when you want to go to a certain point x and y going to a certain point, let us say a comma b, then it can follow a straight line path, it can follow a curve, it can follow some kind of different kind of curves. So, basically it is completely dependent on what kind of path you are choosing. Now, if you are choosing a path depending on the path, if the limit depending on the path, then in that case the limit will not exist. So, it must be independent of the path when you are evaluating the simultaneous limit, and that is why you choose different types of curves to see whether the limit exists or not, because in case of 2 dimensional, the method to approach the limit that x and y going to certain point is not unique in a way. In case of 1 dimension, it is always one direction, and that is why it is very simple. For more details on it, you can look into any analysis book where they are talking about functions of several variables. All right. Somebody has asked Stokes, Gauss and Green's theorem. You will learn about them probably when I will start the vector calculus in the course. So, I don't know whenever I don't know the week's number, in which week I have included Gauss, Stokes and Green's theorem, but you will get to learn them in vector calculus portion. One student have asked for fluid flow analysis, how to understand mathematics. It gives more confusion to understand. First of all, I do teach fluid mechanics, but here we are talking about a very basic mathematics course, which is integral and vector calculus. Now, fluid mechanics is something different. So, there you are most of it I am pretty much dealing with velocity vectors, and you need to be very good at vector calculus and vector analysis, I would say, because in case of fluid mechanics, we are talking about basically fluid flow, which has which is like a vector which has certain direction, it got some magnitude. We can talk about acceleration of a fluid flow. Then there are topics like transportation theorem, Reynolds transportation theorem, principle of conservation of mass, principle of conservation of momentum, angular momentum, several other topics, and there you need to be how to say, quite good in mathematics. I would say at least the basic mathematics. You don't need a very advanced level mathematics, but these are the topic which we are learning at the moment. It's a basic mathematics, and you need to be a little bit good at it, because in case of fluid mechanics and fluid flows, you need them. At least the vector part, you definitely need them. Some students have asked, a function can have both minimum and maximum value at a point. Of course, it can have. Suppose the function is a constant function, then in that case the minimum and maximum will be attained at the same point. Okay, I think one student is asking too many questions on vector calculus. What does unit vector represent? So, unit vector represents that, so first of all, a vector represents that you have as a physical quantity which has a direction, all right. So, vector represents that. So, vectors always talk about direction. Now, a certain any vector, let us say if we are in 2D, then you can write, you can choose a point P and another point, let us say O as the origin, then OP vector will be this 2i plus 3j. So, that is how you calculate the vector. So, OP vector is 2i comma 3j, and it has a direction. Now, when you talk about its magnitude, that will be the mod of OP, and which is given by 2 square plus 3 square root, and then you can calculate the magnitude. Now, for the unit vector, that magnitude is 1. And that is pretty much it. The unit vector, they have a direction like any other vector, but at the same time their magnitude is 1. That is what the unit vector represents. Why unit vector is so important? It is important when you are calculating the directional derivative, because when in case of vector calculus, if you are calculating as I told you, in case of function of 2 variable or 3 variable, your usual limit definition, differentiation definition will not work. So, then you need some kind of modified continuity or differentiation definition. Similarly, for vector functions, when you are calculating how to say the directional derivative, sorry, for scalar functions, when you are calculating the directional derivative, then the directional derivative will be calculated using the unit vector. So, you basically multiply by a unit vector. So, you calculate the directional derivative along the direction of a unit vector, and that is when you multiply by a unit vector. So, that is one application of the unit vector. In fluid flow also, since I believe you are a fluid flow student, you need unit vectors quite often. So, for example, when you are defining the flux on the boundary of a given domain, there n is the unit auto drawn normal, with the help of which you define the diffusive flux, advective flux, total flux. So, that is when you need the unit vectors. So, they are very important, keep in mind. One more question, are vector valued functions and vector fields the same? So, vector valued functions and they somehow they are related, but vector fields are basically they sort of denote that you have bunch of vectors in that given domain, and vector valued function in a way for every value of x, y and z it will give you a vector. So, in a way you can say that vector valued function this vector field will be generated using the vector valued function for every value of x, y and z. All right. One more question is, if the function is not constant, also it is why unit the function is not constant. I don't know in which context you are talking about. If the function is not constant, also it's true. All right. One more question is how to take unit vector when surface is closed and gives projection on more than one plane. I think you are talking about something related to your subject or courses from other than this integral and vector calculus. So, I need to know the theory behind it. I need to know in which context you are talking about, because the question itself here is not clear. How to take unit vector when surface is closed, when the surface is closed and gives projection on more than one plane. I have to know in which context you are talking about, because this question is very vague and it's not related to this basic vector calculus. All right. Okay, I believe one student have asked, a function can have both minimum and maximum value at a point if the function is not constant. Also it's true. So, first of all, if the function has maximum and minimum, you have to define first of all an interval. So, let us say interval a to b, that is where the function is attending its maximum and minimum. So, if it is attending its maximum and minimum, and if the function is not a constant function, then the maximum and minimum they both will be attained at two different points. It cannot be at the same point. All right. Because the minute it will attain the maximum and minimum at the same point, it will become a constant function. So, I believe we came close to the closing of the session. So, I had a very nice discussion on this session, and I also appreciate all the questions asked by all of you. So, I will see all of you next month in our another live sessions, and in the meantime you can ask me as many questions as you want on the NPTEL forum and on this course forum obviously, and I will try to answer them. All right. So, thank you for your time.